So first off, we're factoring when we are looking for the GCF, or the greatest common factor. So greatest common factor just means you're looking for numbers that multiply into that larger number or the whole term, and you're looking for what is the greatest common factor between the 2 or 3 terms that you're factoring. So between these two terms, we have 6x squared and 18x cubed. So for 6x squared, that would just be the same as 6 times x squared. Or we could think about it as 6 times x times x. 18 is the same as 3 times 6 times x times x times x, because x cubed means to multiply x by itself 3 times. So the GCF of our numbers, or the greatest common factor, would be 6, because 6 can be multiplied by 1 to make 6, so it's a factor of itself. So the greatest common factor of the numbers is 6. When we expand our variables, when we expand the variables that have the exponents here, x squared becomes x times x, and x cubed becomes x times x times x. So the two that they have in common here are x and x, right? So they both have at least two x's in them, so they both have x to the power of 2, or x times x. So when we put them together and multiply all of these as one common factor here, the greatest common factor between these two would be 6x squared. That means you could multiply 6x squared by 1 to get back to our original first term. And if you multiplied 6x squared times 3x, then you would get back to 18x cubed. So that's the largest possible amount that you can take out of both of those as factors to find their greatest common factor. So to do the same thing in our next question, we have 14x squared and 12x. So something that I noticed right away is that they're both even, so they're definitely divisible by 2. And aside from that, there's no other numbers that they're both going to have as a common factor. So the greatest common factor of those two numbers is going to be 2. Out of our x squared and x, remember if we just see an x, it's really like x to the first, they really only have one x in common, because this is 1x and there's 2 x's here. So only one of those is in common. So together, as the GCF, the greatest common factor of these two terms would be 2x. So now we're going to put it all together and actually factor out an expression and write it as a different form from what we started with. So our expression that we're given is 18a squared plus 10a. So to factor this expression, we're going to look for the GCF. So between these two, again, we see they're both even, so they're both divisible by 2. And then aside from that, there's no other common factors that they have. So the numerical GCF is 2. And out of a squared and a, the greatest common factor is a. So 2a becomes the greatest common factor of these two terms. So we're going to take this whole expression and we're going to divide it by the GCF, which in this case is 2a. So what that means is we have 18a squared, which means 18 times a times a. And we're going to divide that by 2a, but we're also going to divide 10a by 2a. So when we do this, 18 divided by 2 is 9. One of these sets of a over a turn into one whole, so we're left with 9a in the first term. Our plus sign comes down. 10 divided by 2 is 5, and a divided by a is 1 whole. So we're left with 9a plus 5 after we divide by the GCF. So to write this out in factored form, we put the GCF out front of our set of parentheses, and inside we put what was left after we divided. So this is equivalent to what we started with, and this is considered its factored form. And so to check to make sure you got it right, we can just use the distributive property and make sure that we can get back to what we originally started with. So if you took 2a times 9a, you would get 18a squared, which is our first term, plus 2a times 5, which is 10a. That gets us our second term, and altogether we have the original expression that we started with. So why are we doing this? The reason we're going to do this is because we can solve quadratic functions or quadratic equations using this method when we have a term that has x squared in it. So when you see the following equation, it says 20x squared minus 4x equals 0. Now typically, if these were both just x to the first power, we could combine like terms and figure out what x is, right? We're pretty used to doing that at this point. But right now, we realize that we can't just do that. So what we need to do is whenever you see that power of 2 on your x, you know, okay, I've got a quadratic, I need to factor this somehow. And right now, we're just focusing on the GCF method. So we're going to try that first. So let's look and see if we have the GCF of these two terms. So out of 20 and negative 4, the greatest common factor is 4. And then we have x squared and x, so x would be that other part of our GCF. Then what's going to be left inside? Well, what do we have to multiply 4x by to make 20x squared? Well, 4 times 5 would make 20, and we just need to put another x there. So 4x times 5x would get back to 20x squared. And then 4x needs to become negative 4x, so we don't have to multiply by any x's, but we do need to change the sign of the number, which means we're going to need to subtract 1. Now this is going to take it one step further here because this is an equation. It's not just an expression, so we need to change those directions. These are equations, and we want to find the values of x here. So because this is set equal to 0, we now have two small equations that we can break this up into. 4x equals 0, and 5x minus 1 equals 0. So at this point, we're solving these two linear equations separately. To get x by itself here, we would divide by 4, so x would be 0. And to get x by itself over here, we would add 1 and divide by 5. So x is also 1/5. So whenever you see that x squared in your equation, when you solve, you should get two x values as your solution here. So this will be our first set of solutions. Next up, we have 6x squared minus 18x equals 0. So we're going to check for our GCF first, 6x. And once we do that, we would have to multiply 6x by x. We would have to multiply by negative 3 to get negative 18x. And that's set equal to 0. If you're not sure if you did it right, check by distributing. 6x times x is 6x squared, and 6x times negative 3 gets us back to negative 18x. So you can always do that as a step before you keep going just to check your work. At this point, we can break up our two factors and set them equal to 0. So 6x equals 0, where x will equal 0, and x minus 3 should equal 0. That means x is equal to 3. So our two solutions to this equation are 0 and 3. Go ahead and try the last one on your own and press play when you're ready. For this one, our GCF is going to be 4a. We'd have to multiply it by a plus 2. We'll set each of those factors equal to 0 and solve. So a will be 0, or a will equal negative 2. Now, to take it a step further, we're going to apply these rules to some of our geometry theorems that we learned this year. So you'll notice in the next question, we are asked to find the possible values of x, and we're given a diagram with angle 6 and angle 7, and those are set vertically to one another on a pair of intersecting lines. So that means since they are vertical angles, they will be congruent. So their measures are going to be equal. So the equation that we can set up at the beginning here will be 3x squared equals 6x because they're vertical angles. So in order to solve this, we can't just kind of use the process that we're used to, so we're going to factor by the GCF. So we're going to take 3x squared and subtract 6x from this side, and we'll be left with 0. So once you're left with 0, you can use your factoring method on any equation. So that's always going to be your starting point, is try to get everything equal to 0. We're going to take 3x out, because that's our GCF. We'd have to multiply it by x minus 2 to get back to our original equation. So 3x equals 0 means that x will equal 0, and x minus 2 equals 0 means that x will also equal 2. So those are both expressions here that are going to be our solutions. Now, something you want to check in these instances is now that we're going to be applying this to geometry, we want to make sure that our solutions are actually true for what we are actually setting them into. So the measure of angle 6 is 3x squared. Well, if we apply 3 times 0 squared, right, that would just be a measure of 0. And this angle is definitely not going to be 0. Otherwise, we would have just had a line, and we wouldn't have had those lines intersecting because the other angle next to it would have to be 180. So that's not really going to be possible in our diagram. So we can get rid of that as a solution in this part. And then we can check our other x value of 2. So that would be 3 times 2 squared. 3 times 2 squared would get us 12, and 6 times 2 would also get us 12. So those are equal. And although it might not be drawn to scale, 12 is still a possible value for an angle measure in a pair of vertical angles. So that seems more realistic, and we can keep that as a solution. So although 2 and 0 are both solutions to our equation, only 2 is going to make sense in our diagram. In our next question, we are given two pairs of two parallel lines and a transversal. So when we have a transversal, remember we get our angle pairs. So when they're parallel, we can assume that angle 3 and 7 will be congruent because these are corresponding angles. So because of the corresponding angles theorem, we know that their measures will be the same since those lines were parallel. So since the measures are the same, we can set them equal. So 10b will equal 40b squared, since we were given that information up here. So we're going to find the values of b. Again, we have a variable to the second power, so we're going to need to factor. So the first step here is to get our one side equal to 0, so I'll subtract 10b from both sides. Once I do that, I can factor out my greatest common factor, which is going to be 10b here. I'll have to multiply by 4b and -1 to get back to my original equation. I'll set these both to equal to 0, so b will equal 0, or we can say that b will equal 1/4. So those are our two possible solutions. So right here, again, plugging in our solutions for b, if I plug in 0 here, then I will get a value of 0 for both of my angles. And again, that's not going to be realistic in our geometry diagram. So we can eliminate that answer of b equals 0. However, we can test out the next one, which is 1/4. So if we were to do 1/4, then the measure of angle 3 would be 2.5, and that's really small, so this is probably not drawn to scale again, but that does make sense. At least there is some sort of measure there. We also then want to test out 40 times b squared. So 1/4 squared would be 1/16, and when we divide 40 by 16, we get 2.5 as well. So those two angles are the same, meaning that they are still congruent, and therefore those lines are still parallel. So that value of b equals 1/4 ends up working in our diagram. If you want to try the last one on your own, go ahead and pause and try it and then press play when you're ready. So in this last one, we have angle 4 and 5 on these parallel lines. When we look at angle 4 and 5, they're on opposite sides of the transversal, and they're on the inside of the parallel line. So these are alternate interior angles. Alternate interior angles will always be congruent when the lines are parallel, so we can set these two expressions equal to each other. Once we do that, we want to be able to solve for x, so we want to set this equal to 0 since we have our x squared terms. So by combining like terms, I'll have 0 on my left side. That means I'm subtracting 2x, so 4x minus 2x squared is 2x squared. I'm subtracting 10x, so 6x minus 10x will be 4x. What I'm going to do at this point is factor out my GCF, so 2x, put x here, minus 2, set them both equal to 0. So x will equal 0, or x will equal 2. Now when we check these again, same as before when we plug in our x of 0, none of these are going to make sense because we get a value of 0 for both those angles. So geometry-wise, that doesn't make sense in our diagram. But for the angle measure of 2, 2 times 2 times 2 will be 8, plus 20 will be 28. And if we plug in 2 here, we would have 2 times 4, which is 16, and 16 plus 12 is also 28. So we get two angles that are congruent there after we factored out and got our two values for x. So x equals 2 does work in our geometry diagram.